Okay, for this example, we are looking at calculating trig functions for the angle pi over 3. So what I like to always do, if I can recognize pi over 3 as a special angle, which it is, my friends, pi over 3 is equal to 60 degrees. That leads me to consider triangle. That is a 30, 60, 90 triangle. So I'll draw that just to help us out. And so that would leave us the way I think my triangle is situated. I do have 60 degrees right here, 30 degrees right here. Now, again, if we're looking at the special sides of this triangle, we are labeling each side. We have the hypotenuse is 2. We have a leg as 1 and another leg as square root of 3. And it's really important to understand the positions of these sides based on their particular angles that are opposite. So just to remind you, if we're looking at 30 degrees, the side opposite of 30 degrees is 1. And if we're looking at 60 degrees, the side opposite of 60 degrees is square root of 3. And so you're going to hear me refer to the sides of the triangle as opposite, adjacent, or hypotenuse. And might as well introduce this now to help you kind of see this further. So let's kind of do this with our sines and cosines and tangents. Again, we're looking at pi over 3, which is 60 degrees. If we'd like to calculate the sine of pi over 3, what we want to do is recognize that that is looking at the side opposite of the pi over 3 over the hypotenuse. So the side opposite of pi over 3, and remember pi over 3 is equal to 60 degrees. The side opposite is square root of 3. And the hypotenuse, that's the side opposite of the 90-degree angle, is 2. So now we have the sine of pi over 3. We'll now look at the cosine of pi over 3. And if we're relating this with the sides of the triangle, cosine of pi over 3 would be the side adjacent to pi over 3 over the hypotenuse. So if we look at our pi over 3, our 60 degrees, the side adjacent is 1, and the side of the hypotenuse is 2. So now we have the cosine of pi over 3. Might as well circle the answers as I go, huh? We'll then move on to tangent of pi over 3, and this is defined as the opposite over the adjacent. So again, if we look at the side opposite of pi over 3, opposite of 60, that's equal to square root of 3, and the adjacent side to 60, the leg, is 1. Now notice when you have a denominator of 1, they tend to reduce, so we end up getting a square root of 3. Now, the really nice relationship of trying to calculate the remaining trig functions is that they are reciprocal identities of your sine, cosine, and tangent. So starting off with cosecant, that is a cofunction related to sine. And according to our definitions, and actually I'll write cosecant here. Cosecant of pi over 3 is the same thing as 1 over sine of pi over 3. And as far as legs of the triangle are concerned, you can do the math and see. But if you're talking about reciprocal, it's a lot easier just to say, well, reciprocal of opposite over hypotenuse, just flip that around. We should have hypotenuse over opposite. And if we take the reciprocal of square root of 3 over 2, all we're doing is reversing, writing the 2 in the numerator, the square root of 3 in the denominator. So that is the cosecant of pi over 3. Now, usually that's good enough when we're in pre-calculus and calculus, but sometimes they insist that you rationalize, so they don't like to leave square roots in the denominator. So if we want to do that, we could just multiply by square root of 3 over square root of 3. And an alternative version of our answer would be 2 square root of 3 over 3. So kind of pay attention to the directions, make sure that you are writing the answer in the way that they are specifying. Okay, so let's switch gears. We're looking at secant, and secant is related to cosine. So remember that secant of pi over 3, that's the same thing as 1 over cosine of pi over 3. Let's try to write that a little nicer. And if we're using reciprocal identities, instead of using cosine, which is adjacent over hypotenuse, we'll write the hypotenuse on top and the adjacent on the bottom. So if we are looking at 1 over 2 for cosine of pi over 3, for secant of pi over 3, it would be 2 over 1. And of course, if you'd like to reduce, that leaves us with just a 2. Now finally, on to tangent. We're looking at our cotangent at this point. And this is also a reciprocal identity of tangent. So cotangent of pi over 3 is 1 over tangent of pi over 3. And we can do the same thing with relating the sides of the triangle. If tangent is opposite over adjacent, the reciprocal, or cotangent, would be adjacent over opposite. So all I have to do is look at my particular statement. The opposite is square root of 3, and the adjacent is 1. So that could be a potential answer, 1 over square root of 3. But again, anytime we have square roots or radicals in the denominator, sometimes they want you to rationalize. So we'll do the same thing, multiplying by square root of 3 over square root of 3. And we'll get another version of the answer, square root of 3 over 3. So that gives us a little experience on how to calculate all trig functions of a special angle pi over 3. There are many ways to go, but I guess my preference is relating this to the special triangle and the sides to help you out with this. So I hope this helps. I'll see you in the next example.